Hey everyone, welcome back to the channel. Today, we're tackling LeetCode problem number 4, median of two sorted arrays. This is a classic medium-level problem, often asked in coding interviews, and it's a great way to sharpen your dynamic programming skills. The problem statement is pretty straightforward. Given two sorted arrays, nums1 and nums2, find the median of the combined array. The catch is that we need to do this efficiently, without actually merging the two arrays first. That would be too slow. We're looking for a solution that's faster than simply concatenating and sorting. Remember, the median is the middle value when the numbers are sorted. If there's an even number of elements, the median is the average of the two middle values. We'll explore different approaches, and hopefully you'll find this helpful in your coding journey. Let's dive in. Understanding with examples. Let's solidify our understanding with a couple of examples. Imagine nums1 is 1, 3, and nums2 is 2. If we merge them, we get 1, 2, 3. The median is 2. Now, let's try a slightly more complex scenario. Let's say nums1 is 1, 2, and nums2 is 3, 4. The merged array would be 1, 2, 3, 4. Since we have an even number of elements, the median is the average of the two middle numbers, which is 2 plus 3 divided by 2 equals 2.5. See? It's all about finding that middle ground, even when we have an even number of elements. Understanding these examples will make the solution much clearer. We'll tackle more complex examples as we proceed. Brute force approach. A simple but inefficient approach would be to concatenate both arrays, sort the resulting array, and then find the median. This works, but its time complexity is O of n log n, where n is the total number of elements in both arrays. This is because sorting takes O of n log n time. For large arrays, this becomes incredibly slow. Remember, we're aiming for a more optimal solution. This brute force method is a good starting point to understand the problem, but it's definitely not the best way to solve it, especially when dealing with large data sets or in a time-constrained interview setting. So, let's move on to something much more efficient. Optimal solution. The optimal solution utilizes a divide-and-conquer approach. The core idea is to find a partition point in both arrays such that the elements to the left of the partition points are smaller than the elements to the right. By cleverly choosing this partition, we can efficiently identify the median. We can use binary search to find this optimal partition point. This significantly reduces the time complexity. The algorithm involves iteratively adjusting the partition points in both arrays until we find the optimal split. This clever strategy allows us to avoid a full sort, leading to a much faster solution. We'll see exactly how this works in the coding implementation. Code implementation. Let's see the code in Python. We'll implement the optimal solution using binary search. This code will efficiently find the median by partitioning the arrays. Show code implementation on screen. I've added comments to explain each step clearly. Notice how we utilize binary search to pinpoint the optimal partition in a highly efficient manner. This concise Python code elegantly handles both even and odd-sized combined arrays. Remember, good comments in your code make it much easier to understand and maintain. Time and space complexity. Now let's analyze the time and space complexity of our solution. The time complexity of this algorithm is O of log m, n, where m and n are the lengths of the two input arrays. This is significantly better than the O of n log n of the brute force approach. We achieve this efficiency because of the binary search. The space complexity is O of 1 because we're not using any extra space proportional to the input size. We're only using a few variables. This makes it a very efficient and scalable solution. Engagement break. So, what do you think? Did you find this explanation helpful? If so, please give the video a thumbs up. And if you want to see more tutorials on LeetCode problems and other algorithm concepts, don't forget to subscribe and hit that notification bell. Also, leave a comment below. Let me know which LeetCode problem you'd like me to cover next. Your feedback helps me create better content for you. Conclusion. In this video, we mastered the median of two sorted arrays problem on LeetCode. We started with a basic understanding, explored a less efficient brute force approach, and then delved into the optimized solution using binary search. We analyzed the time and space complexity, demonstrating its efficiency. This problem is a great example of how choosing the right algorithm can drastically improve performance. Remember to practice regularly and apply these techniques to your own coding challenges. Don't forget to like this video, subscribe to the channel, and hit that notification bell